All right, welcome to where the real fun begins with our basic derivative rules of calculus. Normally, this is when I walk into class with a big smile on my face, ready to tell you the true story about derivatives. As you know, in the last unit, we introduced finding derivatives from first principles, so using our limit skills and our algebraic techniques. And as you saw, it is a very long process, derivatives from first principles, and that is why we really only do it when asked. Usually that is one question or one of the first questions on your final calculus exam. So from that homework, these are some of the derivatives that we actually found. So one of the ones that we did together in the video was x squared plus x minus 6, and we found the derivative to be 2x plus 1. Another quadratic that we did was 3x squared minus 4x plus 7, and note the derivative was 6x minus 4. Are you starting to see a pattern in these? We did a cubic function. It did have a coefficient here of a -2, and note the derivative was negative 6x squared. We did just a regular constant function, and the derivative worked out to be 0. You did that one in homework. And a linear function, and the derivative worked out to be 4. So I wonder if you're noticing any patterns here. The first rule that we're going to talk about here is what's called the constant rule. Okay, and that is if I'm giving you a function that is just a constant, f of x equals 3, for instance, what do you think the derivative is? And hopefully your answer is the derivative is going to be 0. The slope of the tangent line is going to be 0. It's actually hard to draw a tangent line in that specific case. So that's your first rule. That is called the constant rule. Okay, if the function is a constant, the derivative is 0. Let's move on to the next one, which is called the power rule, which is a little bit more complex. And hopefully you can sort of see this from above. So I want you to take a look at the ones that we did in last week's homework and the lesson, and let's see if you can guess some of these on your own. A good chance to pause the video and see if you can get the derivatives of the following functions. Okay, so here, let's start off. We've got f of x equals x. The derivative is 1. We have f of x equals x squared, and the derivative of that quadratic is 2x. Note it's linear. We have the derivative of x cubed, so a cubic function. Note the derivative is 3x squared. And finally, we have a quartic, your basic quartic function, and the derivative of that is 4x cubed. Can you see the pattern? Okay, so this is what's known as the power rule. We have a general power of x to the n. What happens? Okay, we bring down the power, then we have an x, and we subtract 1 in the exponent. So that's your basic power rule. That's the most important one. That's the one you're going to use all the time. Now I'm going to show you some more rules that actually have names in this particular section of the textbook. Really, they're all just variations on the power rule. So I remember most of today's lesson as simply the power rule. Okay, let's take a look. Okay, so this is called the constant multiple rule. Again, I really just think of this as sort of the power rule, but note they all have coefficients. So of course, when you take the derivative of the function, the coefficient is just going to multiply by the derivative of the x, or the derivative of the x squared, or the derivative of the x cubed. Okay, so it should follow and sort of make sense. So this is called the constant multiple rule. Let's try a few together, and again, good chance for you to maybe pause the video and see if you can figure out some of them by yourself. All right, function is 8x. Derivative, keep the 8 there. The derivative of the x is 1, and so the final derivative is really just 8. Okay. Function is negative 3x squared. And so the derivative, I'll do this one in 2 steps just so that you can see it. Keep the negative 3 there. And the derivative of x squared is 2x. And so this derivative is negative 6x. Again, I never show that in between step, but I'm just doing it to make sure you can see it. Let's do it all together this time. So the function is 2x cubed. The derivative is 6. So I brought down the 3. 3 times 2 is 6. X to the 2, 1 less than it was before. Okay, and the last one, function is 3x to the 4. Derivative is 12, so that's my 3 times my 4, x to the 3. Okay, there's the constant multiple rule written out like that. Again, really just the power rule, but a little more complicated. And so the last one is what we call the sum or difference rule. And I'll show you the rule first, and then you can try maybe the ones above. Really, it's just saying that if I'm adding two different functions, let's say together, I have this, and I have another function h of x. Of course, we just take the derivative of g of x, and then we add or subtract the derivative of h of x. So just apply the power rule to every single piece or term or function itself. Okay, so let's try the ones above. So here we have x squared minus 2x. The derivative of that, the derivative of x squared is 2x, and the derivative of negative 2x, or subtract 2x, is minus 2. Try another one. You try that one. Pause the video and see if you can get it right. How'd you do? Let's do another one. Okay, derivative of f of x squared plus x minus 6. So the derivative of the x squared term is 2x again. The derivative of positive 1x or plus 1x is plus 1. And the derivative, don't forget, of the minus 6 is 0, right? So we don't include any term for that. And what about the last one? We have just a linear function, negative 2x plus 7. The derivative of that is simply the negative 2. The derivative of the 7 is 0. Okay, again, just a combination of a whole bunch of power rules all put together. Okay, let's try some. So what I want you to do here is make sure you have these printed or written out. I want you to pause the video for each one, and I want you to see how much of it you can do on your own, and then replay the video just to get some of the explanation towards each term. First one, how'd you do? Hopefully the 12x cubed makes sense, the minus 14x makes sense, derivative of pi, remember that pi is just a number, 3.14, so the derivative of that is 0. Of course, that was there to trick you. Try B. Now, for B, it's very important that you understand that the power rule applies to terms that are written like x to the n. So we can't have it written as negative 5 over x squared. We need to write it as a power. So to write this as a power, I'm going to rewrite it with a negative exponent. Okay, and now you're going to treat it exactly like you did before. A little bit on form here, okay? When the function is written using a y, the proper form to use here is the derivative of y with respect to x. That's our Leibniz notation. There is a notation file posted that you can take a look at. It is also okay. This is sort of what I call the lazy way. This is, for some reason, the way I was taught. It is okay to also just write y prime equals, and let's go ahead and take that derivative. Okay, so we're going to bring the negative 2 down, times negative 5 is positive 10. Subtracting 1 from that exponent, we're going to get negative 3. Okay, and then the one rule, of course, here is we write all answers with positive exponents. And so we are going to rewrite that then as 10 over x cubed. And hopefully that one makes sense to you. Okay, pause the video and try C. Okay, one thing that I always do is anytime I have any negative exponents like I had in the previous one or radical exponents, I always sort of write it in power form so that it's easy to see. And then, of course, we can just use our power rule with this. So we have negative 3 times a half, so we have negative 3 over 2. X to the, we have 1/2 minus 1, which gives us negative 1/2. Hopefully that is clear. 1/2 subtract 2 over 2 is negative 1 over 2. And then the next term should be easy. That's a plus 8x. And the derivative of negative 8 is a plus 0. You don't ever need to write the plus 0. Same rules before. We want to write all exponents as positive, and we actually want to write our radical exponents in radical form the way it was in the question. So this one was given in radical form, so you would want to write your answer in radical form. Okay, so let's talk about what this term right here becomes. Okay, so the negative 3 is on the top, or the negative is in front, it doesn't matter. The 2 is on the bottom. we're going to move the x to the negative a half to the bottom, and it becomes x to the positive a half, which is the same thing as root x. So that's the proper way to write that answer, and then plus 8x. Okay, we don't need to form a common denominator here at the end, not yet anyways. When it serves a purpose, we will do it, but for now, I just want you to focus on the rules and making sure that you can understand how to apply the power rule to these questions. So the general rule for our answers is all positive exponents and in radical form. Okay, pause the video and see if you can guess what to do for D. Hopefully you guessed it right. You need to expand it so that it's in power form, in standard form, and then we can apply the power rule to each piece, or the sum and difference rule if you want to call it. So one little note just again about notation, this function is written as d at t, so we're taking d prime of t. We're taking the derivative of d, if you like, with respect to t. Okay, so derivative of each piece, derivative of 4t squared is 8t. Derivative of 3t is positive 3, and derivative of 27 is 0. Okay, I think that's enough for you to get going. There's some textbook questions to work on here, and these should be pretty fast, and you want to master this rule before we add some new rules. Thank you.